So we'll wait for 2 minutes. So once you are admitted, almost all the students, 70 to 80% students are admitted means then I'll continue the class. Yes, my voice is audible. Bharat GM.
Sir.
Okay, I'll mute now. Yes, PPT is also visible.
Sir.
Okay, wait. Now PPT visible, Bharat.
Sir.
Oh, okay, thank you, ma'am. Okay, now we consider a link 4 because the link force applied to a known force, magnitude and direction we know that, external applied force. Both magnitude and direction we know that, that's why we'll consider a link 4. On link 4, see just draw the free body diagram of the slider. In the freehand sketch, you draw the rectangular box. In the middle of the box, you draw a horizontal line. In the horizontal line, an external force is applied, that is P. Right? We know the direction, right? This is the line of action of external applied force towards the body. Next, the link 4 is connected to link 3 and link 1. Again, two more forces are acting on the link 4, right? One is from the link 3 on link 4, it is F34, right? If magnitude of F34 is equal to F43, again it's unknown in magnitude. Direction also we don't know whether towards the slider or away from the slider, but we know only the line of action of F34, that is equal to the line of action of F43. That is, you draw a line which is parallel to link 3. Okay, link 3, draw a line which is parallel to link 3. That means that intersect the line of action of external applied force P. That point you call as a O. From the point where draw a vertical line, because in the vertical, why do you draw the vertical line? Mean the slider slides over the horizontal surface. From the surface here, a normal force exerted on the slider. That's why we'll draw a vertical line here. From the point, draw a vertical line. Okay. Draw a vertical line. That all these three forces are meet at a point. That point is called as a point of concurrency. Then only the body is equilibrium. Then only the body is under equilibrium. Then we don't know the magnitude of the forces. We don't know the magnitude of F34 and F14, and also we don't know the direction, whether towards the slider or away from the slider. Okay, we don't know the magnitude and direction. Then how do you get the magnitude and direction of those forces? Then we go for draw a force polygon by taking a suitable scale here. What is the scale here? Now, what is the total force acting on the slider is, what is the external force acting on the slider is 1000 Newton. Based on this, we'll go for take the scale here. Scale is 250 Newton is equal to 1 centimeter. Now, draw a horizontal line. The first point, the tip of the line, sorry, the tail of the point is called as O. Draw a horizontal line. In what direction here? See, the P is acting in towards left direction, right? In the left direction only, you draw the horizontal line here. Then OA, along the horizontal line, how much you measured here? What is the force P is acting here? 1000 Newton. The 1000 divided by 250, you'll get how much? 4 centimeter. On the horizontal line, measure 4 centimeter, that is OA. The length of the line OA shows what? Magnitude of the force. Magnitude of external applied force. The arrow mark shows the direction. Now from the point A, see after force P, now we'll go for in counterclockwise direction. What is the next force you'll get here? F34, right? I don't know the magnitude and direction of F34, right? But I know only the line of action of F34. Now from the point A, I draw a line which is parallel to the line of action of F34. But we don't know the whether it is draw a vertical line which is parallel to the F34 is a downward or upward. We don't know. Just simply draw a thin line that shows a line of action of F34. Because yes, yes, because you don't know the magnitude of F34, just simply draw a line which is parallel to line of action of F34 from point A. On both sides you can draw here. But make it as is a line of action of F34 only. Then after F34, what is the next force here? F14. The F14 is in doing the magnitude direction. Know the line of action of F34 in vertical direction, vertical line here. Then from where you want to draw here? From point 4, because the force polygon, there is no resultant force. Whatever, if you draw the force polygon for the link number 4 is subject to 3 forces, it should be a closed force polygon. That's why we'll take the from point 4, draw a vertical line that shows the line of action of F14. The line of action of F14 and line of action of F34, the meet at a point. That point is called as a B. Now measure the line AB. The line AB shows the magnitude of F34. Measure the line AB shows the magnitude of F34. The F34 is equal to what? AB. Multiply the AB is how much you got? 4.25 centimeter. Sorry, 4.2 centimeter. And multiply the scale. What is 1 centimeter is equal to? 250 Newton. Then you will get F34 is 1050 Newton. That is a magnitude. Then F14, measure the length of the line OB. F14 is equal to OB, that is equal to, you will get 1.15 centimeter and multiply the scale. 1 centimeter is equal to 250. Yes. Measure the F14 is equal to OB. Yes, my voice is audible. And also slide is visible. Someone has to give the response. Hemant D.
Yes, sir.
Okay, thank you, ma'am. Now F14 is equal to OB. F14 is equal to OB. Measure the distance OB, that is 1.15 centimeter you get. Multiply the scale. What is the scale? 1 centimeter is equal to 250 Newton. Then you will get F14 is how much? 287.5 Newton. Now we know the magnitude of F34 and F14. But what about the direction? How do you get the direction? Now we'll start from point O. O to A, it is what? Towards left direction. Again from point A, I want to reach to O, initial point of the polygon, force polygon. Then how do you reach here? From A to B, downward. From B to O, upward. That arrow mark shows the direction of those forces. To transfer the directions of those forces to the free body diagram of the link 4. That's why you'll get see the F34 is towards the slider. F34 is towards the slider. F14 also it is towards the slider only, is upward. Now, once you get the magnitude and direction of the forces and acting on the link 4, F14 and F34, now transfer that force to the each part of the mechanism. Now, see the link 4 is connected to what? Link 3. Now, F34 is equal to F43, but act in opposite direction. See that this F34 is in this direction, F43 is away from that direction. Act in opposite direction. After this, again see that the link 3 is subject to how many forces? It is subject to only two forces. When a body is subject to only two forces, how do you say it is equilibrium condition? Means that for those two forces should be equal in magnitude, act in opposite direction along the same line of action. You can see that F34 is equal to F43, that is equal to F23. That is how much force here? 1050 Newton. Then transfer that force to link 2. Again, link 2, see the free body diagram for link 2. Link 2 is subjected to how many forces? Two force and a torque. Now make it correction here. This is the wrong notations we use here. Force convention, right? Yeah, now this is F3, 2. This one is F, the force exerted by member 1 fixed link on the link to F12. Make it correction. Now F32 is equal to what? F32 is equal to F23, right? Yeah, F23. Now that, but act in opposite direction. See the F23 is acting in this direction, F23 is acting in this direction, F23 is acting in this direction. Now F32 is equal to F32 is equal to, now again make it correction. Okay, F23 is equal to F32, then that is equal to F12, not 4 here, it is 2. This is a 2, this is also a 2. Now you can take 2 here. Okay, the magnitude is the force, the magnitude of the force is same, but act in what? Parallel to each other and acting in opposite direction. Then that produces F32 and F12 is produces what type of couple here? It produces a counterclockwise couple. Then we need to go for apply a torque in what direction? In clockwise couple. Then from any one point on the link on the line of action of F14, you take here, or on the line of action of F34, any one point you take here, draw a line, a perpendicular to that line of action of F34. Okay, then we'll get h. H is nothing but perpendicular distance. How much you get? 3.2 centimeter. The 3.2 into what is 1 centimeter you chosen here? 1 centimeter is equal to 3 centimeter, or 1 mm is equal to how much? 30 mm. Now substitute here. Okay, substitute here. Now we'll get 96 mm, that converted into a meter. That is a perpendicular distance. After this, our aim is to determine what? A torque. What is the formula for torque? Torque is equal to force into perpendicular distance. What is the force here? F32 or F12 you take. Now this is equal to F1, 2, that is equal to F3, 2 into H. Now F32 is how much? 1050 Newton. F1 into H is how much? 0.096. Then we'll get torque is 100.8 Newton meter. That produces what direction here? Clockwise direction. Now the body is under equilibrium. The slider connect mechanism in equilibrium condition. Now try to solve this problem. You may get any questions, any doubts, please contact my number or put a question. I'm trying to solve that your questions. Or in next class also you can ask me the question. Okay. Any doubt? If you have any doubt, so when you get doubt, if you try to solve the problem, then you try to understand that, analyze the problem, then you'll get the doubts. Otherwise, you won't get the doubts. Okay. Yes, this is the today's class. We discussed only the analysis of slider crank mechanism, and also we solved the problems on slider crank mechanism. Keep in mind that those three keep in mind that those the static equilibrium equation, three equilibrium equations, static equilibrium equations such as when member is separated to a two force, yeah, equilibrium of two force on a member. When member separated two forces, what will be the condition? Second one, when member separated to three forces, if it is make a equilibrium, what will be the conditions? Third one, when member separated to two force and a torque, right? Then what will be the conditions? Okay. Then after that, remember these 6 steps. Then only you can easily solve the problem. Okay. Yes. Now try to again. You have a time. I think we'll take the class in next Monday only because Thursday is holidays there, right? Now try to solve, try to use the engineering, the tools such as set square, protractor, compass, pen, pencil, eraser. Try to solve, okay, in A4 sheets or in your rough notebook. If you now you'll get the doubts. Now you can clarify your doubts by putting a question in WhatsApp number, or directly you can contact me. You can call me and clarify your doubts. Okay. Yes. Any doubts is there? Now any clarification is there? You can ask here. Otherwise, I will end this session. Yes. Any doubts?
No, sir.
Yes. Yes. Number 42.
Yes, sir.
Any doubt, ma'am?
No, sir.
Hmm.
By the way,
Katela?
happy Engineers Day, sir.
Sorry.
Happy Engineers Day, sir.
Thank you. Thank you.
To all my friends also.
Yes. Okay, shall I wind up the class?
Abdul Wasim CR, sir.
Sorry? Yes? Okay. Thank you, guys. Thank you for attending the class. We'll meet on next Monday. Okay? Thank you, one and all. Yes, now we'll leave the meeting.
Jai Wasim.